A warm welcome to all of you. Today we will discuss about one more example, spam detection using artificial neural network. So if you can see the title introducing spam detection using neural networks, notice how a neural network architecture gradually appears on the screen. Three red circles on the left labeled x1, x2 and x3 representing email features, keywords, sender, links. Moving right, we observe two hidden layers with blue colored circles h1, h2 and finally a single yellow output neuron labeled y on the far right. See how thin gray lines connect every neuron between layers and yellow numerical values appears along these lines. These are weights that determines how strong each connection influences calculations. Above the input neurons, values appear 0.7 for keywords, 0.4 for sender and 0.9 for links. Yellow bias values labeled with B appear above hidden and output neurons. Below each layer, labels materializes input layer, hidden layer 1, hidden layer 2 and one output layer. Moving ahead, forward propagation. Watch very closely the title changes towards the forward propagation and small yellow dots emerge from the input neurons traveling along connection lines towards the hidden layer. Look at how this visually represents information flowing through the network. Simultaneously, a calculation panel appears on the right side showing step-by-step mathematical calculation to calculate the z value. Z is equal to w1x1 plus w2x2 plus w3x3 plus bias with actual values substituted. Notice how the intermediate z value gets computed, then the sigmoid activation function is applied. A is equal to sigma of z is equal to 1 by 1 plus e to the power of minus z, transforming values to a range between 0 and 1. Activation values appears below hidden neurons and their circles fill with blue color, indicating they are activated and ready to pass information towards forward. The same process repeats for the second hidden neuron also. Now watch very closely, yellow dots emerge again from hidden layer 1 to traveling towards the hidden layer 2. The calculation panel updates showing how previous layer activations become new input h1 of 2. Z is equal to w1 h1 of 1 plus w2 h2 of 1 plus b. Each neuron undergoes the same z calculation and sigmoid transformation. Resulting activation values appear below these neurons and their circles fill with blue color. Signal dots then move from hidden layer 2 towards the single output neuron. The calculation panel focuses on the output y. Capital Z is equal to w1 h1 of 2 plus w2 h2 of 2 plus bias. The sigmoid function is applied one final time, producing an activation value between 0 and 1. This value appears below the yellow output neuron and the circle fills prominently with color, signaling forward propagation is complete. Moving ahead, activation function and spam prediction. A brief section appears showing the sigmoid formula. Sigma of z is equal to 1 by 1 plus e to the power of minus z, explaining it maps any value to a 0 and 1 range. This creates a probability like values that help us interpret predictions. A rectangular box appears next to the output neuron. If the output exceeds 0.5, it displays spam in yellow with a confidence percentage. If below 0.5, it shows not a spam in blue. This translates the numerical output into a meaningful spam detection result we can understand and use. Moving ahead, backward propagation learning process. See what will happen. The title changes to backward propagation error calculation. An error calculation and its related assessments. You can see very clearly the yellow dots begin moving backward through the network from output towards hidden layers, opposite to forward propagation. This visually represents how error information propagates back, signaling to each layer how much it contributes to the prediction error. The calculation panel shows backward propagation formula very clearly to calculate the existing error in the model. The weight labels along connection lines begin changing colors to red systematically from output layer backward through all connections. This visual cascade shows the network learning from its mistakes, adjusting every connection weight proportionally based on how much each contributed to the error. So finally, if we can see the summary, the artificial neural network from this assessment will have 5 different summary aspects. Moving from forward propagation shows data flowing from input through hidden transformations to produce predictions. The sigmoid activation function maps all values in between 0 and 1, enabling probability based outputs. Output judgment converts numerical predictions into meaningful spam detection categories. Backward propagation shows how error flow backward to identify corrections. The learning process illustrates how network improve through iterative weight adjustments. Comes to the 3 email features: keywords, sender, links entered the input layer as normalized values, then flowed towards forward through 2 hidden layers via weighted connections where each neuron applied sigmoid activation function to transform inputs into probability like values between 0 and 1, with yellow dots moving along connection lines, while a calculation panel displayed step-by-step mathematical operations in right side for easy understanding, and the output neuron produced a final prediction value interpreted as either spam or not a spam based on 0.5 threshold displayed in a color coded decision box with confidence percentages that translated numerical output into meaningful spam detection classifications. We could understand and can understand the related phenomena. When prediction error were detected, backpropagation reversed the signal flow completely. Yellow dots traveled backward through all layers in the opposite direction, while the calculation panel showed how errors converted into weighted adjustments, signals that proportionally modified connection weights throughout the entire network. Every weight label changed color to red as adjustments were made, creating a visual cascade for learning happening simultaneously across all connections, demonstrating how the network learns from its mistakes by fine-tuning every connection weight based on how much each contributed to the prediction error. The entire forward and backward cycle represents one complete learning iteration, demonstrating how neural networks simultaneously improve their predictive accuracy through iterative weight adjustments, making increasingly accurate spam detection predictions as the network processes more examples and learns from its mistakes, gradually becoming better at recognizing patterns that indicate whether emails are spam or legitimate messages. Thank you.